Hey Kevin. So we will solve the question number 2.16 from the Dasgupta book. Do you have the PDF version of that book?
Yes.
Okay, so I gave all the students 10 minutes to discuss that problem among
Okay.
themselves, then we'll solve it here. So I will assign you to one breakout room. Is that okay?
Okay.
Okay. Yeah, welcome back everyone. So anyone wants to discuss the solution for 2.16? No one. Okay, let me go over the question first. So the question says that you are given an infinite array A in which the first 10 cells contain integers in sorted order, and the rest of the cells are filled with infinite. You are not given the value of n. Describe an algorithm that takes an integer x as input and finds a position in the array containing x. If such a position exists in big O of log n time. So anyone has any idea how to solve that?
Can we use binary search?
Yeah, exactly. So how will you use the binary search?
So I think we need to have like the array which has only the integers, and then find the middle point or the middle index of the array,
Mhm.
and then if the x is in the root, that's all right. Otherwise, it could be on the left or the right. So in this case, it will be log n.
Yeah, but the thing is that as the length of this array is infinite, so if you apply binary search, suppose 3, then suppose there is 100, then there is infinite and infinite. So you may end up somewhere here. You may hit infinite. Then how do you come out of that? You don't know how many elements are there, and you cannot also divide the number of elements into two parts. You have to apply binary search, but how will you apply that? Any other ideas, guys?
I was thinking about like picking a random point, but I'm not sure how to go from there.
Mhm. Okay, good try, good try. Anyone else? Or I will
I'm
discuss this.
sorry. Can you
Mhm.
repeat the question?
Okay. So the question says that you are given an infinite array A.
Oh no, what you meant? Yeah, what you meant about traversing the infinity.
Mhm. So if you directly apply binary search on A, then you cannot divide the array in two parts, as infinite divided by 2 is undefined. You do not know the exact number of elements in the array A. So I was asking, how can you apply the binary search?
Wouldn't we have a left and a right in order to be able to do that?
Yeah, you have to have one left and a right, but you don't know the exact length of that array. It is not given to you. So you have to modify the binary search a little bit to apply it on this array.
Couldn't we just pick a random point and then check if that random point is greater or equal to the thing that we're searching for?
Mhm.
And
If
then if it's greater, just work with the right bound.
mhm. If it is infinite, then what do you do?
Throw an error.
No, you cannot throw an error. You have to find that element n inside this array. Your idea is kind of right, but it is not 100% correct. You have to do something like that, but you cannot throw an error.
Since first n cells are sorted, I think we
Yeah.
can specify that we can use that fact, and we can specify the like a subarray thing, and then we do the binary search. How about that?
Yeah, yeah, close to the answer, but you don't know the actual value of n. The value of n is not given to you. Don't know how many number of how many integers are there in this array.
Would we be able to, for example, find, set it, have like a mid is equals to left plus r plus left over 2?
Yeah, but you don't know the upper bound here. Don't know the r. R is not given. Yeah, so all of you have tried well, and yeah, many of you are close to the answer. So one thing that you can do here is that you can try to find the number of integers by uh, accessing the elements a1. First a1, if you hit infinite, then you stop there. Otherwise, you continue to a2 to the power 1, which is a2. So this one was a2 to the power 0. Okay, so a2 to the power 1 is a2. So if you hit infinite, then you stop. Otherwise, you continue. In this way, you go to 2 to the power I. Then again, if you hit infinite, you stop. Otherwise, suppose at a2 to the power k, you get infinite. Then you stop there. That means that a2 to the power k minus 1 is not infinite. It was some integer, right? Is it? Is this part clear what we are trying to do here?
Yes.
Okay. So yeah, we are basically progressing through this array in the power of 2. We are trying to find at what power of 2 we get infinite. It means that all the elements before that, most of the elements before that were integers. So then when we get a2 to the power k is infinite, then we perform a binary search in the subarray of a2 to the power k minus 1 to 2 to the power k. There we will find, there we'll perform the binary search, and there we will find the n, because this is not infinite and this is equals to infinite. So n must lie somewhere between 2 to the power k minus 1 to 2 to the power k. Is it clear what we are doing here? Any question, guys, from this part? Any confusion? Yeah, a lot of you came very close to the solution, but it was not 100% correct. Your initial ideas were good, really good. But you have to do something like that to find the n. And as the runtime of binary search is big of n, big of log n, sorry. The runtime of binary search is big of log n. So the runtime of this algorithm will also be big of log n in the worst case. It will be actually less than that, big of log n. As there are, yeah, go ahead.
Just out of curiosity, how would you make that into code? How would you input that to the k minus 1?
Oh, for the first part, you have to determine the value of k, and then you have to take the subarray of a from a of 2 to the power k minus 1 to 2 to the power k. You may define it as b. Then you just have to apply the binary search on that subarray b. Is it kind of clear?
Okay, I think I got it. Maybe. Mhm.
Any other question, guys?
I have a question. So
Mhm.
how can we make sure that x is in that array B?
Oh, so as the array A is sorted and n is the highest value in the array A, so you know that 2 to the power A of 2 to the power k minus 1 was not infinite, right?
Yes.
So it have to be, and 2 to the power k was infinite. Is it clear?
Yes.
Yeah. So as the array A is sorted, so n has to lie somewhere between 2 to the power k minus 1 to 2 to the power k.
Okay. Yeah. Yes.
So that's what, that's how we can say that n will lie between this one. So we are taking this property that A is sorted in for our benefit to design this algorithm.
Okay. Thank you.
Any other question, guys? From this one? Okay, so let's move on to the next question. Next, we will discuss question number 2.22. So I will give you guys 10 minutes. Then we will meet here to discuss the solution. I'll send you to breakout rooms now. We will meet here at 1:40 p.m. Welcome back, everyone. So, anyone has any idea on how to solve this question? Let me read the question first. So it says that you are given two sorted lists of size m and n. So give an big O of log m plus log n time algorithm for computing the kth smallest element in the union of the two lists. So any idea on how to solve this question? Anyone?
Would you just have an algorithm and check out the lowest and highest point, maybe in case once you merge the two arrays, maybe it's sorted in descending or ascending order?
Yeah, you can merge them or you can keep them separate as they are already sorted. If you merge them, then you have to sort that array. So it will take some time. So it might exceed the time limit of big O of log m plus log n if you want to merge them and sort them.
Wouldn't you just compare the value of both of them at that point? And if they're both true, then return?
Yeah, you can try that. So how would you do that? Can you please describe that?
Well, what if you compare, I guess, for say example array A, the first array, just check the first value,
Yeah, let's
and
consider
then
A has
yeah,
one,
and then
two.
compare it to the value of the
Mhm,
first one on array B,
mhm.
and if the array A is smaller than B, then just return 1 or the first position of A.
Okay, you are saying that if A1 is less than B1, then we return A1?
Yes, something like that. And then recursive, you can do a recursive method to do the
Yeah,
high
that's
point.
correct. Yeah, that's correct. You have to do something like that, but
Just
yeah, yeah, go ahead.
out of curiosity, are we in ascending or descending order?
Ascending order. Yeah, go ahead.
One question that just out of curiosity, let's say if it is asking for fifth smallest element,
Mhm.
that means we have to get the fifth element from array A and again fifth element from B. Then we can just compare fifth element of A with fifth element of B. Then whatever is the smallest one, that is the smallest element, correct?
It might not be true because you have to find the fifth smallest element in the union of A and B.
Ah, okay.
Fifth
Okay.
smallest in A or fifth smallest in B might not be the fifth smallest in the union of A and B.
Yeah, that's correct. Sorry.
Yeah, that's fine. That's fine. Any other ideas, guys? Yeah, you guys are getting close to the solution. Any idea works. Anyone
Would we find the medium?
median?
So yeah, so we would add the value from m and n of the k that we're searching for, and then divide by 2.
Yeah, but for that you have to have the combined array. But I am suggesting that
Oh,
you don't combine them. Yeah, you guys are getting close. So one hint is that you can use binary search, as you can see, it says big of log m plus log n. So the runtime of binary search for any array of length n is big of log n. So whenever you see something like that, you can always think about binary search. You have to apply some kind of binary search on these arrays.
Okay, so binary search both of the arrays and then just get the smallest integer and then compare them. Which one has the smallest one?
But you have to find the fifth smallest one or kth smallest one. So you know that the first element will be the smallest one. Then the second element will be the second smallest for A. It might not be the second smallest for B. They might have repetitions. So yeah, you guys are getting close. So any other idea? Yes.
Is it like a search for the ith element of one
Yeah,
array and the
similar,
other array
similar
and
to that
compare
one.
them?
Mhm. Yeah, you have to do something like that. So let me give one other hint. So if the kth smallest element exists, then it has to be greater than k divided by 2, k by 2 smallest element. So you can divide k by 2 instead of dividing that. Yeah, the number of elements in A or B in 2 parts. So anyone want to try this idea? How do we get from there? We have to search for the k by 2 element, and we know that these two arrays are sorted.
So
Mhm.
search for the k by 2th element in the other opposite array and return either the bigger or the smaller one.
Yeah, something like that. You don't have to return. You have to apply binary search. So how can you apply binary search? You have to find you have to find the k by 2 element in both these arrays. Then also you have to compare them. Then you have to apply some kind of binary search going forward. How can you apply binary search after finding the k by 2 element in both of those arrays? Any idea? So Huing Chen is saying binary search A and binary search B. But you have to find the kth smallest element in the union of A and B. So if you perform separate binary search, then you will not be sure about the exact location of that element in the union of the two arrays. Okay, so let me discuss the solution. So first of all, we will get the AK divided by 2 element and BK divided by 2 element. So they can either this one can be greater than that one, or this one can be smaller than that one, or might be smaller than this one. So suppose AK by 2 is greater than BK by 2. then we will know that the union of those two arrays A and B will have K minus 2 elements that are smaller than B, K by 2. So those elements are A1 to K, K divided by 2, floor of that minus 1. All these elements in A, and then in B, we have 1, 2. Ceiling of K divided by 2. So all of those elements will be smaller than Bk divided by 2. Is it clear? Okay, so
I'm sorry, what happened to that K minus 2?
yeah, so if we have that Ak divided by 2 is greater than Bk divided by 2, then we can say that in the union of A and B, there will be K minus 2 elements that are smaller than Bk divided by 2.
And how do we know A is greater than B?
Oh, this is one case. So there might be 3 cases, right? Ak divided by 2 is greater than Bk divided by 2, or Ak divided by 2 is smaller than Bk divided by 2, or they are both equal.
Got you. And we would do it for every case, correct?
Yeah.
So will we have our base case be if they're equal, then just return? Or if they're null?
Yeah, if they're equal, then we will return that. So we'll say S is the smallest element, K smallest element. Yeah, so if they're equal, then we will have K by 2 elements from A and then K by 2 elements from B. So in the combined array A and B, we will have K elements, right? So if they are equal, then Sk will be the element at Ak by 2. Is it clear? The case for if they are equal?
I believe so.
Okay. Any question? If they are equal, then how are we getting the K smallest element? Okay, so if they are not equal, then we will have K minus 2 elements, which will be smaller than Bk by 2. And all the elements from A1 to floor of K by 2 and from B1 to ceiling of K by 2, they will also be smaller than A K by 2 plus 1, right? Is it clear? Any question?
I guess maybe it's that I'm not understanding the question. So it's just two sorted arrays.
Yeah.
You don't have to merge them, but you have to find the k smallest integer. It can be from either 1 to the end of it.
Yeah. Yeah. You can merge them, but then the runtime will exceed if you merge them and then apply binary search. You have to merge them, then sort them, then apply binary search. So this runtime will exceed our required runtime.
Okay, and then what you're doing at the bottom where k divided by 2 is that you're saying the k is a position on the array
Yeah.
and you're dividing it by 2 because it's two arrays and you're trying to figure out which of the two is the smallest.
Yeah, exactly. So the question asks you to find the kth smallest element in the combined array. So you have to devise some algorithm which can find that in big of log m plus log n time, where the array A has m elements and B has n elements. Is it clear, the question? Okay, so let's continue. So as we can see, there are k number of elements less than a k by 2 plus 1, right? Because the sum of these two numbers will add up to k. So our smallest element, it has to be less than a k divided by 2 plus 1. Any question? Okay, so from here we can say that Sk must be located somewhere inside A1 to k divided by 2 and b k divided by 2 plus 1 to k. For that case, when a k divided by 2 is greater than b k divided by 2. Is this part clear? So is it clear? How are you getting these limits? Okay, so we will recursively apply this algorithm for these two limits. Then our subarray A will be replaced by A1 to k divided by 2 and subarray B will be replaced by k divided by 2 plus 1 to k. Then we will recursively apply this algorithm on these two subarrays. And for the case when a k divided by 2 is less than b b of k divided by 2, it will be similar. Just these two will get exchanged. Is it clear? Okay. So that way we will modify the binary search to find that kth smallest element. And for the runtime, as so the runtime of this algorithm will be big of log k, and we can always assume that k is less than m plus n. For k to exist, it must have to be less than or equal to m plus n. Then we can replace this here, and we will get the runtime of this algorithm to be big of log m plus n. So it satisfies our constraint. And this will be our algorithm, which will solve this problem in big O, within big O of log m plus log n time. Any question, guys?
Could you give us like a small example of going through the process? Because I kind of lost. Yeah,
Okay, maybe.
thanks.
We try something like that. So suppose k equals to 3, we have to find the third smallest element. So first we will divide k by 2. So k by 2 is 1.5. And we will take the floor. We'll take the floor of that. Floor of this is 1. So a k divided by 2 is a1, which is 1. And b ceiling of k divided by 2 is b of 2. So b of 2 is 5. Okay. So here the case will be this is smaller than b divided by 2. So is it clear?
Yes.
Oh. Mhm. So then we have to find the third smallest element must lie between that limit. Yeah. So here these two will get exchanged, and the limit will be b1 to k divided by 2 and a. So comes out to be So basically saying that the third smallest element will lie between these locations, which are for A it is 1 and 5, and no, for B it's 1 and 5, and for A it's 1, 2, and 3. So we have here 1 and 5, and then for it is just 3. Is it clear? How are we getting this thing?
Yes.
Mhm. Okay.
Sorry, I do have a question.
Mhm.
When you exchanged them, you took the ceiling of B again
Yeah.
on the second time?
Yeah, second time was.
Okay. And then you take the ceiling of both of them?
No, for the small. So the formula is something like this one. So for the for the bigger one, it has to be floor, and the smaller one it has to be ceiling. Maybe okay. Let me check. Yeah, this one will be floor. Yes. Thank you for correcting.
Okay, sorry, it's just it wasn't making sense before. Thank you.
Yeah. Okay. So this will be just one and that. Okay. Yeah. So the smallest element must lie somewhere here. So then we will get then as there are only two elements, we'll just compare them, and B1 and A3, and then we will find SK max of them. Which is 3. Okay. So here, as you can see, the third smallest element for the union of these two arrays is 3. So that way we find that way this algorithm can identify the kth smallest element in big of log m plus n time. Is it kind of clear from this example how we are applying this algorithm?
Yes, it's getting clear for me. Thanks.
Any other question? Any confusion? Okay. So we can end our lab here, and I will publish these notes in the Canvas. You can have a look there to see these solutions in detail. Anything else, guys? Something you are confused about or something you want to discuss? I think Dr. Ina will have the exam review, not me. Okay, so if you don't have any other question, then I think this is it for today's lab. See you all again, and
Excuse me.
yeah, go ahead.
I have a question, but about the previous note in a Canvas, you put it as a lab note.
Okay, yeah, we can discuss that. Yeah. Okay, so let me stop the recording, then we can discuss that. Is
Thank
that
you.
okay? Mhm.
Yeah.
Okay. Any other question, guys? I think there will be a lab next week. I'll let you guys know if something else, if the lab get cancelled or something.
And then, do you think right now you can help me out with question 1 on the homework?
Yeah, we can discuss that.
Okay, I'll be here.
Okay, so